Hi ladies and gentlemen, this is Ms. Skokin, and we are going to have a lesson on confidence intervals for difference in proportions. In previous lessons, we've talked about confidence intervals for proportions, looking at just one sample. Now what we're going to be doing is taking a sample from each of two different groups or two different populations, and we're going to be comparing them through subtraction or difference in proportions. Let's start by reading the paragraph together so we know the setup of the problem. At many high schools, prom is an annual dance that only juniors and seniors can purchase tickets for. The student council at a large high school is wondering if juniors or seniors are more likely to attend prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. They take a random sample of 45 seniors and 29 are planning on attending. Construct and interpret a 95% confidence interval for the difference in proportion of juniors and seniors who are planning on attending prom. Okay, I'm going to go back now and I'm going to highlight specific information that's going to be important to us as we analyze this question. The reason that they tell us that it's coming from a large high school is so that we know our population size, uppercase N, is large enough for our sample sizes, lowercase n, to meet the 10% rule. Our research question is really, who's more likely to attend prom, juniors or seniors? With the highlighted red information, we know two bits that are important to us. Number one, we have a random sample. Number two, the lowercase n, the size of the sample of juniors, and also the value of those 50 juniors that were sampled that are planning on attending prom. That's going to help us figure out our P1 hat. Likewise, what I've highlighted in green is the information that we took a random sample of 45 seniors. That's going to help with our conditions, and also the number of successes so that we know that 29 out of the 45 are planning on attending. That's going to give us our P2 hat. Last of all, we have the confidence level that we need to be using, which is 95%, and what our confidence interval is going to represent, the true difference in proportion of juniors and seniors who are planning on attending prom. Okay, let's take a look at number one now. As we work through the difference in proportions, in order to find a difference, we use subtraction. So we need to know which of our proportions is going to be P1 and which one is going to be P2. And that's basically going to tell us which proportion is being subtracted from which. As we read through the question, you probably noticed it said difference in proportions of juniors and seniors. Since juniors was indicated first, we're going to use P1 for the juniors planning on attending the prom, the proportion of juniors, I should say. And we found out that 28 out of the 50 that were surveyed are planning on attending. That gives us a proportion of 0.56. When it comes to the seniors, we want to know the proportion of seniors planning on attending prom. That's going to be P2 hat. And that proportion is 29 out of 45, which gives us 0.64. Last of all, we want to know what the difference in proportion of juniors and seniors planning on attending is, and that's going to be the P1 hat minus the P2 hat. And that is a difference of negative 0.08. So far, just based on our sample proportions, we do have an indication that fewer juniors or a smaller proportion of juniors seem to plan to attend prom when compared with the proportion of seniors planning on attending prom. Next, let's check conditions. We're going to start with random, and we know that 50 juniors and 45 seniors were randomly sampled. Next, we check the 10% rule, and remember the commentary about the large high school. So this means that 50 is less than 1/10 of juniors at the large high school, and 45 is less than 1/10 of the seniors at the large high school. Last of all, we need to check the large counts condition, and this we need to do for both juniors and seniors. So at this point, we know that we're trying to estimate the difference in proportions, the true difference in proportions, and we've checked our conditions. So we are ready to move forward with constructing and interpreting a 95% confidence interval for the difference in proportions of juniors and seniors who are planning on attending prom. And we're going to start with the general formula that we can find on our formula sheets. Once we've got the general formula, then we can plug in the specific formula for difference in proportions using all the appropriate variables. Starting with our point estimate, P1 hat minus P2 hat, then we have our plus or minus and our critical value, the Z star. Then we've got our standard error formula. So let's just do a quick detour and remember what we learned in Chapter 6 about combining random variables. You may remember that when we combine random variables through subtraction, the mu sub x minus y is equal to mu sub x minus mu sub y. When it comes to standard deviation, though, we need to use the Pythagorean theorem of statistics, which shows us this formula. And if that's a little fuzzy, go back and review either your textbook or the class notes on Chapter 6, combining independent random variables. So I'm just going to put this in a little bubble right now, and then we're going to go back to our formula, and we're going to continue filling in the rest of the margin of error. We have our critical value Z star, and now we need our standard error formula. So it's going to be a combination of, through subtraction, of P1 hat, let's see, 1 minus P1 hat over N1 plus P2 hat times 1 minus P2 hat over N2, and then we're going to take the square root of all of that. And that is what we're going to plug into now with the actual values from our problem. So again, this is coming from the information that we learned in Chapter 6 about combining random variables, or independent random variables, I should say. So the difference that we found a little while ago is our P1 hat minus P2 hat, and then we've got our plus or minus. The Z star for a 95% confidence interval, you may remember, is 1.96. And now we're going to plug in the numbers that we calculated based on our samples. And then the square root of those. Okay, so when we plug this all into our calculator, we end up with our confidence interval. Remember that we're going to write it both ways. The first way that we're going to write it is using that plus or minus notation. And the other way that we're going to write it is using interval notation. Now, just a reminder, when you do this, you need to be using 3 decimal places all the time as a minimum. In this example, I'm using 2 decimal places, but in future examples, we're going to be using 3 or more. So let's continue on. We're ready for our the conclude part of it right now. And we always start out with, if you remember, we are 95% confident that the interval from negative 0.28 to positive 0.12 captures the true difference in proportion of juniors and seniors planning on going to prom. The conclusion probably feels very familiar to you, as that's the same format of the conclusion that we learned for confidence intervals of individual proportions, one sample. Anyhow, our last question, number 4, before we get to our box of important information on the next page, says, does the interval provide convincing evidence that juniors have a lower proportion planning on going to prom, or is it plausible that there is no difference between the 2 classes? Explain. Now, no difference means that when we subtract, we could get 0. That's what no difference means. The 2 values are equal. And so what we do is we look to our interval. And if 0 is part of our interval, then yes, it is plausible that there's no difference. So we go from negative 0.28 to positive 0.12. 0 is included in that interval. So our response to number 4 is going to be that it is plausible. I'm going to write that down. You can pause the video to copy down the exact verbiage so that you're comfortable and familiar with the wording to use. All right, so at this point we are ready for our box of important information on the next page. When it comes to confidence intervals, we are still going to be using the state, plan, do, conclude 4-step process. We start state with, we wish to estimate the true difference P1 minus P2. In our state, we need to include the confidence level and what P1 and P2 are standing for. Next, we're going to look at plan, and we're going to say if conditions for inference are met, we will construct a 2-sample z interval for P1 minus P2, and then we're going to check our conditions. For do, we start with the general and then go to the specific. And so always start out with what you see on your formula sheet, point estimate plus or minus margin of error, then show your formula, and then plug in the numbers. The conclude should be phrased, we are, and then whatever your confidence level is, like 95% confident that the interval between, give the two values, captures the true difference in proportions, P1 minus P2, of, and then give the in-context information. You notice that I left some space on the right-hand side. This is where we're going to write down how we use the confidence interval to determine whether or not we have convincing evidence. What we're going to be looking for if we're trying to find convincing evidence of a difference is the value that we're looking for within our interval. Very frequently, the question is there a difference, meaning are the values the same or not? Are the true value, the true proportions the same? Are they equal to each other? So a difference of 0 when we subtract them. It could be a different research question, but that's often what we see. So what we look for is that value within our interval? And when our interval is two positive numbers, plus, comma, plus, then that means that the first proportion was greater, the one that we're subtracting from, and we ended up with two positive values when we add and then subtract, or subtract and then add. And that means that 0 is not within our interval. So we do have convincing evidence that there's a difference. It's a positive difference. When we have a minus and a minus, that's evidence that the second proportion is greater. 0, again, is not within the interval. And that means, again, we do have convincing evidence of a difference, but this time the second proportion is greater. When our interval goes from a negative number to a positive number, as it did in the example that we just finished, we have no convincing evidence of a difference because the interval contains 0. All right, next we've got our check for understanding that you will be working on independently, and then turning on the video when you're ready to check your answers. Remember, as you go through it and read it, highlight the important information so that you've got it when you need it. I'll see you back in a few minutes to check your answers. Here's the completed check for understanding question. Please make a note of the detail involved, of the wording in which we explain things, and the way that we show our general formula first and then the specific formula. If you have any questions, let's talk about them when we're in class together. At this point, you're ready to do some practice problems from your textbook to make sure that you can create a confidence interval in the state plan do conclude format independently without looking. And remember that the answers in the back of your textbook are abbreviated, so you definitely need to use the state plan to do conclude format. And if you have questions, let's talk about them in class. That's it for this lesson. Confidence intervals for difference in proportions.